Good morning, everyone. This session is Developing with Berkeley DB and Oracle Database Mobile Server for Java Embedded. And I'm Hinkman Wong. I'm an engineer from the Java Embedded group. I'm here with my colleague, Eric Jensen. He's the product manager for Berkeley Database and Database Mobile Server. We have a small group here, so if there's any questions along the way, let's just make this informal and show me your hand, and I'll call on you, and you can interrupt me as I'm going through my slides. That's no problem. It's an intimate crowd, I should put it that way. So here's our safe harbor statement, just to make sure that all the information that we're describing in our slides are for informational purposes. And I'm going to go over the agenda. We'll be covering today an overview of Java Embedded. So how many here, by a show of hands, have heard of Java Embedded technology? Okay, so you guys know some of it or most of it, and I'll just touch upon the overview. So if there's anything you want me to dive in deeper, just let me know along the way. And then I'll go over Java Embedded development, since that's the group I'm from, is the engineering development group of Java Embedded. I'll go over some of the issues that we've come across. And then this session specifically is about tying the Java Embedded technology together with Berkeley Database. So then I'll switch it over to Eric, and Eric will go through the rest of the slides of the presentation covering Berkeley Database with use cases. So that part's very interesting, how Java Embedded customers today are using Berkeley Database. And then he'll go over Database Mobile Server. How many here have heard of Database Mobile Server? Okay, so he's going to go mostly in depth onto that and Berkeley Database, just because since this is the topic of the talk and it seems like it's geared for this crowd. And then also give use cases for Database Mobile Server. And then we'll wrap it up with how you can get started programming with the Database Mobile Server and for Berkeley DB using Java Embedded. So just giving the value proposition or the advantage that you get with Oracle's Java. Across the board, you see from the left side, you have the big servers, the app servers, and now what's known as mobile servers are also showing up on the back end in the data centers. This set of devices span all the way down to the right side, which are mobile clients. And this is happening in an enterprise where you have your servers on the back end serving up your clients that people carry around with them in their pockets, such as the smartphones of today, tablets, and also embedded devices where you find in fixed assets that are non-movable. And these are all smaller pieces of equipment now where Java still runs by spanning from the left side to the right side. And what you get are the gray lines connecting the old style way of a server to client type of information transfer. And this has been shown to be very effective also in the consumer world, not just the enterprise world, where you might have a back-end server that serves up Facebook data and user information, and that travels across the internet, the gray arrows there, to your mobile device. So you get applications like the Facebook iPhone application, for instance, moving across to your device, which is going to access data. And in the enterprise world and in Java world, you can do that by having Java Enterprise Edition, Java EE, running on your app server, and then having that data interact with Java ME or Java Embedded clients running on your mobile clients. So you get this orange cloud here of Java technology, and that's the single unified platform and language for Java that spans from your servers on the back end down to your mobile devices. Now we're introducing the mobile server, where Eric is going to go into detail more about that, where you can take your database mobile server and then synchronize all the data and applications from that mobile server down to your mobile devices. That's what you're seeing in the darker gray arrows. Synchronization and management from your mobile server to your smartphones running Java ME, to your tablets running Java Embedded, and your embedded systems like network routers or printers, multifunction printers, or any number of devices that have these ARM chips and Linux running on them. That's a very common place to run Java. And of course, since you know Java Embedded, it seems like this crowd already knows about Java being deployed on billions of devices already, from anything from these toy robots down to smartphones and feature phones. And you also see a car there. That's the Audi car that Eric worked on. That's running Java real time. And there's multifunction printers, the Kindle from Amazon, Blu-ray players. That's all running Java embedded. And this includes not just the consumer side of things, but also there's industrial and enterprise. There's medical equipment, industrial controllers, smart grid, smart meters, and so on. So you know the goodness of Java Embedded already. It's a proven and stable platform. There's a huge developer base because people that understand Java SE will be able to program for Java Embedded. Unlike Java ME, where you have to think in different terms of subsets of APIs, Java Embedded is a full set of the Java SE APIs. Also, you get the goodness of Java. You get fully object-oriented, runs on virtual machines. There's memory management. And now, with all the ARM chips becoming multi-core and multi-processing, you want to be able to take advantage of that also, and Java does that automatically under the covers for you. So you get multi-threaded support, multi-processing support, and multi-core support. And then, of course, very importantly, the security and networking of Java comes along with Java Embedded. Now, here's the difference that you see, and I directly worked on Java ME CDC, which was a subset of the full spec. Now with Java SE Embedded, you get the full implementation of the Java SE spec. And so that's really important because every time there's something new that shows up in Java SE, so for example, Project Coin or Project Lambda, that will show up in our Java Embedded. And you know, you could look at other Java, in quotes, type platforms where they don't do that. They're not keeping up with Java 7 and Java 8. You have to scratch your head and wonder, well, if I'm trying to keep up with Java technology, what's the best way to do that? And Java Embedded is the best way because we keep up with the language and the spec as it moves forward. And of course, we address that since you're running on an embedded device, we want to make sure it's a smaller, persistent, static footprint size, and it uses less dynamic memory than your desktop Java SE does. So you'll see that our engineering team goes in and makes sure this version, Java SE Embedded, runs appropriately for Linux ARM and for embedded devices. So we go in and do optimizations, especially runtime optimizations, while keeping the full spec. And so you get this spectrum, and you've seen this slide before many times. We go from Java goes from servers down to Java card. What we're talking about in our presentation today is embedded right in the middle there under the robot. You have Java Embedded, Java SE Embedded, and that's the corner block of Java SE in the red under the platform. There you get the full Java APIs that you would need to program your device. If you were talking about Java ME, if you go a little bit to the right here in the slide, there's TV and mobile, and they have special APIs they need to change the channel of your television or to record and play on your Blu-ray on Blu-ray player or on TV set-top box. Those APIs are extra on top of the Java platform, so that's why that's a little different. That's more of a vertical market that we address with Java ME. In Java SE, again, since we're trying to match the Java SE spec for desktop, we're a horizontal platform, more general purpose for programming in Java. And what are the best practices for Java Embedded? How is it best used? Well, the main concern you'll have when you're addressing these devices that I showed in the previous slide is that you want to manage your limited memory. So on these smartphones, feature phones, on these multifunction printers, you don't have the 4 gigabytes of RAM that you have on your desktop or even your laptop computer. So there's ways of making sure your static initializers are optimized. It's not grabbing megabytes of data in arrays and byte arrays. You want to make sure you're doing lazy memory allocation. So on demand, whenever you need that megabyte of byte array, don't do it. Don't allocate it until the very moment that you need it. So put that off. And we found that is a big help, especially in our Java core libraries. Also, you want a way to limit your footprint size. So there's, in the future, ahead of time compilation that we'll provide in Java Embedded. And that allows you to convert your Java bytecodes down to an intermediate language closer to machine language, so that the JIT compiler, the virtual machine of your embedded device, can turn that into machine language very easily without having to process all the bytecodes and class files. Also, you want to limit your use of threads. Even though you have these multi-core processors, you don't want to burn up cycles on these ARM processors that have multiple cores, even if it has dual core or quad core on it. And that's because every cycle that you're wasting is eating up your battery life. So that's very important on many mobile devices, such as tablets these days, is you want to extend your battery life, and one way to do that is watch how many threads you're using in your application for embedded. Also, you're dealing with these lower power CPUs, so the processing that's available is not as fast as what you get on desktop or laptop. So remember, even though there's some chips that are 1 gigahertz, they're not the 3.3 or 3.7 gigahertz i7s that are running on your desktop machines. So the predominant CPUs nowadays is ARM, and that's what you have to keep in mind, is what kind of advances are they making with ARM chips, and how fast and how speedy will your application run. Also, because all these different types of best practices are great to understand and to apply, where would you use that in the marketplace right now? And again, there are embedded devices such as even the Raspberry Pi, which is a target device that you see a lot mentioned here at Java 1 this year. It's a target device that's meant for test and development. So when you're doing your proof of concept, you're going to see that the use of that CPU, the ARM CPU there on the Raspberry Pi, is going to be very different than your desktop system. So you have to make sure to apply the best practices there. Also, on smaller memory and lower powered CPU devices, such as the smartphones, they're really trying to keep their bill of materials very low cost on these devices, since they're consumer devices. So you'll see the lower power chips there. And most of the time you're going to have a wireless network. Sometimes you have a 3G network, such as the WhisperNet on Amazon's Kindle. That's actually Sprint's 3G network that they piggyback onto. That is great because you get this broadband connection to the data center in your back end. Sometimes you might have to count on it being intermittently there if the person's within reach of a 3G cell tower. And so you might want to adjust your app programming because of that, because you can contact a back-end server at some point, then make your embedded applications with the best practices optimized for memory, be able to do bursty types of communications with a data server, not this continuous connection that you have with desktop or laptop. And then also on the UI side, you have to make sure to account for things like headless use on a network router. There's no screen, no set of buttons that you're pressing. So you have to make sure you're programming your application to handle that and be able to be configurable even if it's headless. Or it might have just a small screen, small LED screen. And then you want to make sure to address the input device, such as a limited keypad or a touch screen. How is the user going to enter in data, and how much data will they be able to do on this limited device? Then there's the different platforms that I talked about on the diagram, the layer diagram. There's SE Embedded, which has a small footprint, and it's fully Java SE 1.6 compatible. There's Java ME, which shrinks it down even further by subsetting the Java SE spec. And then there's Java Card, which is the smallest. And again, just as a recap, is SE embedded is meant for large commercial industrial use for fixed location assets. That's like a multifunction printer. It's sitting there in the print room. It's not going to move around with somebody in their pocket as they're walking around. On the ME side, that's where you get the mobile devices such as a tablet or a smartphone. And this is dominated mainly in Java by the feature phone. And then you get Java Card, which is used a lot on M2M networks for security and authentication, and also on cyber physical systems. So that was a brief overview of Java Embedded, just to get a perspective and a scope of what's coming next. And I'm going to hand it over to Eric, and he's going to take you into the Berkeley database part and how that is used along with Java Embedded.
Thank you, Hinkman. So these products are what we're going to be talking about today. They have several use cases, but the one we're going to focus on today is really networks of embedded devices, or machine-to-machine networks, where you have a large amount of data that you need to manage and effectively transport between the devices, but also connecting to a back end. And at the same time, database mobile server actually allows you to manage the device network as well. But first we're going to be looking at Berkeley DB, which is the database you would run on the devices themselves. This graphic will give you an idea of the areas where Berkeley DB is typically found. From left to right, the range we have here is the data center all the way out to the edge and really past the edge to mobile devices. On the left, we have Oracle database and more times 10 in your caching type functions, and after that is where you start to see Berkeley DB traditionally in things like gateways, authentication, caching, logging servers, and so on. But increasingly, we're seeing demand for this database also on mobile devices. This slide focuses in a little bit on the different areas where Berkeley DB is used. What makes Berkeley DB interesting is that it's kind of complementary to Java in that it's a ubiquitous data store that can be used either on the back end to handle the data as integrated into a server, handle the data that you would serve out to a network of mobile devices on some type of always-on appliance, let's say, that was designed to manage this network really without human intervention, just continuously handling the requests, making sure that everything is functioning the way it should. The other option, of course, would be on the right side of running Berkeley DB directly on the mobile devices. And there's a number of use cases we're seeing where companies are looking for really robust, scalable data management on mobile devices as they're collecting more and more information, pulling in from sensor networks typically, but other sources as well for analysis and so forth. Berkeley DB is an embedded database. And the reason for that is that embedded databases have a much lower latency than a traditional RDBMS due to the fact that there's simply much fewer layers than an RDBMS. On the left there, you have all the different layers you would find in a conventional RDBMS. So you would have your JDBC, you have a TCP IP layer, and then an actual network connection normally. Although you can run the RDBMS on the same box as your application, but you still have all those other layers in there, the SQL parser, the optimizer, and so forth. Whereas with Berkeley DB, it's just your application code and the database. Berkeley DB does have a SQL API you can choose to use, so you would have some of the extra layers in there added back in if you chose to use that. We'll go through now the main characteristics of Berkeley DB, describing what it is. Number one thing to remember, Berkeley DB is, as I said, a library that links into your application. The idea here is to provide very fast but highly reliable and scalable local data storage that is also recoverable. As I mentioned, it's used extensively in the middle tier, edge, and mobile or embedded applications. The overall goal of this database is to allow you to do more with less. So Berkeley DB has been designed to provide you with the fundamental features that you need to manage your data, but it's sort of a no-frills database. It allows you to capture and manage huge amounts of data, but typically for a single purpose. And that's what makes it very well suited to embedded or M2M networks. Going through the product feature review, the basic aspects of Berkeley DB, number one, it scales to terabyte data sets. So for mobile or embedded applications, it actually scales well beyond what the hardware could currently support. It's very good with concurrency, multiple readers and writers. What this means is in M2M type scenarios where you have a gateway and you have hundreds or thousands or more of smaller devices that need to feed their information into a gateway, Berkeley DB would be the ideal database to run on that gateway. A real world example of that, for instance, would be in a car. The different electrical control units in the car feeding data into one central location, they need to be able to do that asynchronously because they're very usually inexpensive, not very intelligent devices. And the database handling all that needs to be able to accept connections as they come in. Berkeley DB is very reliable. We have multiple customers deployed in proven scenarios that are 5 nines or better. 5 nines is somewhere in the neighborhood of a couple minutes of downtime per year. Fully ACID transactional, small footprint, Berkeley DB is also secure. In addition to the inherent security you get of compiling your database into your application, you get the added security of available encryption. Berkeley DB is an open source product, and we've worked hard to integrate it with all major IDEs, including Xcode for Apple, JDeveloper, Microsoft, the GNU toolchain for Linux, and so forth. There are multiple APIs available. You can actually choose to use a key value API if latency is your primary concern, or a SQL API. And it can actually be configured to operate fully in memory if, again, if speed is a main concern. Some of the trends that we're seeing that have really been driving the adoption of Berkeley DB recently. Number one, a preference for open source technology. This is really being seen across the industry. Many of the new startup companies are fully open source now. Another one is that data is really getting pushed out of the data center. It's on mobile devices, on devices in far-flung locations of your network. It's not, the idea of all your data being in one location and being served out from that location is definitely evolving. The services that run on this data are expected to be available 24/7 by 365 and without someone quote unquote operating them. They need to just run. So these are appliances that you plug onto your network. They're configured to do a single specific purpose and really do that forever. And I'll have a couple examples of that later on. For web services and SaaS, the requirements really tend to be speed, scalability, reliability, and availability. Availability meaning typically that you would use a database that has some kind of high availability mode where if a portion of the network goes down or a machine goes down, the database can fail over to the other remaining databases. That's actually a capability Berkeley DB has for the server side. On the business side, we're seeing pushes to reduce development time and at the same time reduce cost and risk. One of the best ways to do that for embedded development is to use proven technology wherever you can. The last one that we're seeing is a focus on the core competency of the company. Rather than trying to engineer everything in-house, again, using proven technology from outside that you can rely on, ideally open source, so that you know that the rug won't be pulled out from under you at any point, is becoming more and more appealing to people. We'll look at some use cases now for Berkeley DB. These first two are really good examples of the server-side applications I was talking about. This one is Adaptive Mobile. They have a content protection engine that runs in, this is soft real time by the way, not hard real time. So This is for a network of mobile users. The content protection engine needs to make a decision on whether a certain piece of content will be allowed or not in enough time that the experience is imperceptible to the user. So there will be a blacklist or whitelist or both running on the server in Berkeley DB, and every piece of content that comes through will be checked against those lists. This is a similar use case from Cisco. You've probably heard the old adage about the trade-off for any development project. You can have fast, good, or cheap. Pick any two. Actually, as it happens, sometimes you can have all three, as it was with this case. Cisco replaced a object-oriented database with Berkeley DB. We ended up being faster than the original solution, more scalable, and actually cheaper in the long run as well. Here's a quote from the Cisco engineer to that effect. This one goes in a little bit of a different direction. This talks more to where we see things headed, and definitely to what Hinkman was mentioning with Java embedded. In this use case, a Department of Transportation of a certain country has chosen to embed Berkeley DB enabled sensors in a large road-based network for traffic monitoring. This is exactly the type of solution that I'm talking about, where you have to know that it's going to basically run forever. You can't have technicians out on the roadside reflashing firmware. Even if the firmware could be deployed wirelessly, it's still not something that they want to mess around with. These sensors, once they get smashed into the road, they need to be confident that they're going to run for as long as they're scoped to run without any software issue whatsoever. We're seeing more and more use cases like this in a variety of different industries, but I would say the top ones would be healthcare, smart meter, and industrial manufacturing, so industrial automation. Ooh, also automotive telematics. This one I put in, this is back more on the server side, but this happened recently, so it's worth pointing out. You've probably heard of Yammer. They were in the news not too long ago for being acquired by Microsoft for quite a large sum of money. Yammer was using one of the popular newish open source projects that are out there. I forget which one, but they ended up switching to Berkeley DB to power their enterprise social networking platform. And the reasons they did that were what I've already mentioned, the scalability and also the stability. And it allowed them to focus on their core value add, which was this enterprise social networking platform, which Microsoft found to be quite valuable, to the tune of over $1 billion. From here, we're going to look at database mobile server. This is the connecting piece for your M2M network. Berkeley DB enables the storage on the device itself, but you need something to get that data off of those devices and onto your back end. And at the same time, you need a way of managing all those devices and understanding what's going on with them. Database mobile server provides both those things in one package. Tying it all together, here's a very high-level diagram of how database mobile server works. You have application subscriptions, and your devices out in your network can subscribe to those applications, and with that subscription comes a data flow. So the data flow is tied to the application. Once you get the application, you have access to the data flow as well. And what I mean by that is that your local database is now linked to the back end without you having to do anything else. And changes that you make locally will be replicated on the back end and vice versa. So these solutions are designed for any type of deployment where you need the best of both worlds. Yeah, I'm going to stay on this slide to finish talking about this. And by the best of both worlds, what I mean is you need the data on the device so that you're not relying on the network for the device's operation. But you also need the data on the back end where it can be, where number one, it's secure, and number two, you can perform any type of analytics or whatever function you need to do with that data. And it'll all be collected in one location without you having to go out and constantly grab it all the time. The value proposition for a database mobile server, or DMS for short, can be broken down into three pieces. Number one is autonomy. As I said, the device can perform its primary function without dependency on the network, the database, the web server, the application server, all those pieces that normally would need to function if you develop the network in some other way. The device is no longer dependent on that. So this is very popular in any scenario where you have a device moving around constantly through a 3G network that comes in and out. Or in a healthcare scenario where actually there's a demo you'll be able to see, I'll talk about this later on, but in a healthcare scenario where the data needs to stay in the hospital bed, in the room with the patient in case the doctor needs to come in there in a case of an emergency. But it's also needed on the back end where it can be stored and analyzed for diagnosis and so forth. Total integration. The idea here is that Database Mobile Server provides not only management for your data streams, but the devices as well. The unified management console allows you to check on the status of all of your devices. You can check on the status of your applications. You can force a synchronization if you want the latest data snapshots and so forth. The last one is security, which is very important in embedded scenarios. A lot of the data that's being collected by our customers is very sensitive, and we take security very seriously. I'll talk more on that towards the end of the DMS portion. Getting into the technical details a little bit, Database Mobile Server can be broken down into 3 groups of pieces. For developers, and I assume that most of you in this room are developers of devices, you are going to want to focus on the Mobile Development Kit, or MDK. This is a set of tools that will allow you to develop your applications. It could be for Java or native applications as well that will link into Database Mobile Server. Just quickly, in case anyone is actually interested in understanding the total solution, the other pieces are the Sync Server and Mobile Manager Console, which are the pieces running on the back end. The Sync Server is the piece that handles the data synchronization. The Management Console, as you might expect, is where you would manage your devices, and it's fully integrated. So you're also managing users. For mobile deployments, you would probably have a single user for every device. For embedded, you might have a single user for all the devices, or maybe for specific geographical regions or something like that. Anyway, however you choose to do it, you can manage everything from one console. The last piece is the mobile client, which as developers you would develop with that mobile client, and once the application is packaged up and ready to go, the mobile client will be in there in the form of either a library or a standalone executable. The choice is up to you. And once that application is pushed out to the device, it will handle the synchronization, and if you choose to enable it, the device management as well. This is a list of our platform support. Actually, I'll just pause here and see if there's any questions on what we've gone over so far, or on this slide. Okay, we'll keep going. This is a review of the features that I've been talking about so far of Database Mobile Server. The important thing to remember is disconnected mode of operation. Anywhere where the device operation is of tantamount concern that it is able to operate in an uninterrupted fashion, you want to use Database Mobile Server. Anywhere where latency is a concern and you need the data immediately available for, not even if it's not a requirement, but just more pleasant operation. A lot of the background of Database Mobile Server is in field personnel. Guys that are so-called, the saying goes that they're either up a pole or down a hole. They go all kinds of crazy places where there is no cellular signal still. And what we saw is kind of a dip in popularity a few years back of these types of products as people thought that 3G and 4G and so on would really kind of save them from having to do this. And then a few years ago they all started coming back, realizing that it wasn't working out. And their mobile workers were having a lot of issues in the field. And ultimately, though, I think that these type of solutions have a place for the foreseeable future until we reach maybe decades out some type of ubiquitous gigabit low latency network. You're going to want synchronization. In addition, Database Mobile Server provides secure, selective access to the backend data. So you don't need to synchronize data that's unneeded. As I mentioned, we offer remote management and diagnostics, and the most important piece of that is remote mobile provisioning. So the main reason people choose to enable device management would be, once you've got that device management agent on there, future versions of the application can be pushed out from the mobile manager console without you needing physical access to the device any longer. In addition, you can remotely wipe databases, you can remotely check on the database, you can perform other commands. I'll get into that more later, but it's a pretty powerful system. Here's a peek into it's really a high-level diagram, but the architecture for how the client side would work. In your Java embedded device, you're running your mobile application with a local database, Berkeley DB and SQLite. And the beauty of this solution is that's the only database you ever need to worry about. These databases are very easy to develop for, and there's plenty of examples online, and it's generally just not a problem. Once your data is stored in the database, the sync engine is going to take care of everything else. It's going to, based on the rules that you define, sync that data up with your back end. And then what you end up having in the back end is a huge set of data from all of the devices you have out in your network. As I mentioned, if you choose to run the device management agent, you get a bunch of other really cool remote features. I'll go into a little bit more detail about that in the coming slides. But first, looking more at what synchronization allows, it uses a publish-subscribe model. As I mentioned at the beginning, you will publish application, and with that data flow, and then applications will authenticate and subscribe to those publications. It supports data subsetting, so you don't have to just synchronize tables. You can actually get as specific as synchronizing specific rows or columns out to your devices. The conflict resolution is also very advanced, and that's important, especially in scenarios where the data is being modified both on the back end and out on the client simultaneously. You can define rules based on arbitrary data in your database or from other sources about who will win on a very specific basis, on a per value basis for conflict resolution. And the system is also fault tolerant, meaning it's designed to succeed over multiple failed attempts iteratively over a shaky network. That can be very useful in 3G type scenarios in places where network coverage is still spotty. In addition to everything here, synchronization can be set up to be automatic and bidirectional. Application management. This is one of the cool remote features I was mentioning. Once you bootstrap the client, you can then manage your applications remotely. You can check on the configuration, you can pause, resume, uninstall applications, push out new versions to entire networks of devices all at once from a single back-end console. In addition to that, we have the device management. So looking at the device itself, you can check on the health of the device, you can disable the device if you needed to do that for some reason. You can, or just choose to lock it down temporarily. All these kind of things are possible. A few more words about security. We offer encryption support at every layer. And what that means is the data is encrypted at rest on the device. It's encrypted in transit as well. We have externalized security administration if you choose to use it. We have our own as well, but you can integrate with a variety of Oracle security products. The most important of those is called Oracle Platform Security Services, which is a set of standardized Java APIs that's designed to enable the best security practices for Java applications. And then lastly, by virtue of being able to control your app and data subscriptions, you really get an extra measure of security on top of other types of implementations. Okay, so I've got a couple use cases for you, and we've saved some time for Q&A at the end. I chose these two use cases because both of them are available at this conference for you to check out today. I have a bunch more if you're curious I could just talk about. I don't have slides, but once we get through these. But these two are important because you can see them right after this if you choose to. The first one is from a company called mFrontiers. This is a relatively new company, but they're doing some really cool things. And what they've enabled is a role-based application management system that sits on top of our database mobile server product. The idea there would be that you could define a role for a given user, and that user could also be a device, and then all the rest of the management of the applications is taken care of for you automatically. So it will push out whole groups of applications based on the nature of the device. This becomes interesting as you start to think about more advanced M2M networks. For instance, in a hospital, you would have different types of sensors hooked up to the bed. In a car, it's the same thing. You have different types of sensors sitting around in the car. These types of scenarios, we're going to need more and more management of these devices, and mFrontiers has taken our product and really built a very nice management layer on top of it for those types of scenarios. They're over in Moscone if you want to check that out. This one is right over in the Hilton, and I think this one is pretty exciting. What we've, actually it's not on the slide, let me just mention, this is I think booth 5605 in the exhibition hall of the Hilton. That's 5605. What we've done here is built a Java-powered M2M pulse oximeter, which is a device that measures the oxygen content of your blood and the pulse as well. And this is a real thing. It's not a simulation. We have a live pulse oximeter at the demo. And what it will do is it will take a reading using this M2M device and then automatically publish that data to the back end. From the back end, and this is the really cool part, the doctor would be able to subscribe to the data that is linked to the patients that he's assigned to, and he would just see that automatically on his mobile device. And so really you have the data in every place that it needs to be. Number one, as I mentioned earlier, the data is in the hospital by the bed where it needs to be. If something were to happen with the patient and the nurses have to come in and assess the situation rapidly, the data is there and they can see it. That's the most important place. Number two, though, is on the back end where we can do analysis on it. And in healthcare, there's a lot of talk right now about healthcare analytics where you can picture these huge decision matrices where someone is exhibiting these three symptoms and you say, okay, if the next thing that happens is this symptom, it's one of these 5 things. If it's this symptom, it could be any of these. If it's this symptom, run these tests. And this is based on historical data from other patients. So you need the data from everyone, anonymously of course, on the back end to build up these kind of systems that will improve the health for all of us. The last place the data needs to be is with the doctor who is under greater time demands and resource demands now more than ever on his or her mobile device where they can do the diagnosis anytime at their leisure, enabling them to give the best service, but also keeping that data secure because it is sensitive patient data. So I encourage you all to go take a look at that demo. This is a live demo. Every piece of this is actually functioning on the mobile device. The back end all is actually on the form of a laptop for the demo, and then the M2M Java device as well. How to get started. So this is a very brief introduction to a complex problem. And I want to be frank with you. So the pieces that we're offering here, this is a little bit more complex than writing just let's say a very basic Java application. But it does enable you to do something incredibly powerful. And we're not aware of anyone else who's doing this stuff yet today. So once you have your Java embedded device, you're going to want to install the Mobile Development Kit, or MDK. From there, you want to take a look at the documentation. I've actually got the QR code up there. I don't know if it will work. But there's a link in the presentation as well for you to check out. And that will start to give you an idea of the steps needed to set up all the different moving pieces. And the learning curve can be a little bit steep at first, but once you get over that hump, you'll find that you're able to do some very powerful things with this technology without having to write any additional code. And that's something we're very excited about. There's our disclaimer again. I don't think I gave away any secrets, but anyway, there it is one more time. So we're into the Q&A section.
Eric,
yeah.
I wanted to remind you were going to mention the hands-on lab.
Thank you. So the first thing, before we get into the Q&A, we have a hands-on lab about Java embedded platforms tonight. It's at 7 p.m. but you should go anyway. There's going to be, for every person, there's going to be a Shiva plug Linux platform available for you to program Java on. And the guy who wrote that healthcare demo that I just told you about is running the hands-on lab. So if you want to get some first-hand knowledge of how to do that type of thing, you want to go to that lab tonight. His name's Jim Connors. You can tell him I sent you. But anyway, the important thing to highlight there as well, I mean, Jim Connors is a very smart guy, but he built that solution by himself in a few weeks, working in his spare time. He's actually one of our sales consultants, so that's not his primary function. So again, he's a very intelligent guy, but that gives you an idea of what's possible with this technology. Quickly, some links. This is more of the blog and social type. Hinkman runs a great Java embedded blog. He's an excellent blogger, and I recommend you all read it. It's funny. It's always topical. I read it for entertainment value, actually. Seriously. And he gets quite a few hits.
I try to cover Java embedded, Java mobile sometimes. So
it's a good
check out
blog.
the URL if you want.
My blogs are okay. You should read them, but I'm not making the same promise as I am for Hinkman. The Berkeley DB blog and mobile and embedded are the ones that I maintain. There's good stuff on there, but Hinkman's better at it. We also maintain some LinkedIn pages. These will all be in the presentation that's available for you to download. And then I run a couple Twitter accounts as well, my own and then the Berkeley DB account. Here's a couple more QR codes about the products, and that takes us into the QA. Are there any questions I can answer for you? Yes, sir.
I know currently mobile database server is only support the Oracle database. And do you have any plan to support other database, for example, MS SQL or other database? Because some customers use the MS SQL and they want to use Berkeley DB and mobile sync server, but mobile sync server doesn't support MS SQL, so we do not recommend.
So there is a long answer to this question. I'll try to get through all aspects of it very quickly. Number one, it's true that we only support Oracle database on the back end, and we chose to do that because we're able to optimize for that database and make the system very fast and very efficient, which we feel is important for the customers. Now, of course, your point is a very good one, that people want to use other databases. So there are alternatives available for them today. Those would be, number one, the most recommended would be to use Oracle Golden Gate to replicate between the two databases. There are other replication options available, so you would still need an Oracle database, but if their deployment is relatively small, that could be a cost-effective solution. There's a number of heterogeneous replication options available that you could use today. The other option we are considering, again, this is, remember the disclaimer and so forth, we are considering other options to replicate directly from DMS out to other databases. We're looking at the business case for that, I would say. So it's definitely not something that is on the roadmap, but we should talk more about that offline. Any other questions? Okay.
Looks like we covered everything then.
Yeah, I think we did. So thanks everybody for attending this morning. I hope you got out of this what you were expecting, and just flashing these, I don't know if I can go back actually, I was going to put up, yeah. You can find us on LinkedIn, you can find us on Twitter, you can find our blogs, find our products, and thank you for your time today.
Thank you very much.